Hello students, let us continue Module 4. In this lecture video, we will be studying the different topics using Yak grammars, recursive rules, shift or reduce, reduce parsing, and what Yak cannot parse. So these are the topics we are going to discuss in this particular lecture video. So let us see what is the grammar. Lex recognizes irregular expression, but Yak recognizes entire grammars. So Lex recognizes only irregular expressions and it generates the tokens, but Yak recognizes the entire grammar. Lex divides the input string into pieces tokens and then Yak takes these pieces and groups them together logically. So Lex, that entire input string, Lex will take and it will divide into different token group of token. Yak will take those group of tokens and it will generate the parse tree. Yak takes a grammar that we specify and writes a parser that recognizes valid sentences in that grammar. So Yak will take that grammar and it will recognize that valid sentences in the grammar. It will check whether the sentence is valid or not. A grammar is a series of rules that the parser uses to recognize syntactically valid input. Based on a grammar, that parser will identify whether this input is valid or not. For example, let us see one grammar. Statement generates name equal to expression. This is the grammar. Statement generates name equal to expression, and expression, it generates number plus number or number minus number. So the vertical bar, it means there are two possibilities for the same symbol. That is, an expression can be either an addition or a subtraction. This vertical bar means either this expression, it can be a number plus number or number minus number. Here statement can be name equal to expression. This is an statement. Now the symbol to the left of the plus is known as left hand side. This expression is called left hand side, and this number plus number, it is called right hand side or RHS. Let us see the usual way to represent a parse sentence is a tree. For example, if we parse the input Fred equal to 12 plus 13 with this grammar, the tree would look like figure. So suppose how to generate a parse tree for the input Fred equal to 12 plus 13 by using that previous grammar. This sentence generate name equal to expression. So first we'll write sentence generates name equal to expression. So here name can be a Fred, then equal to, and this expression what we can write? Expression, it can be number plus number, because here 12 plus 13, so it is number plus number. So we will write first part of RHS number plus number. So expression, it can be number plus number, and this number value is 12 and this number value is 13 and this name is Fred. So this expression, it can be generated like this parse tree. Next is recursive rule. What is recursive rule? The rule recursive means if function calls itself, that is called recursive function. Similarly, here rules that can refer directly or indirectly to themselves is called recursive rule. So a rule, if it refers to itself directly or indirectly, then it is called a recursive rules. For example, expression generates expression plus number, or expression plus number, or expression minus number, or here it may be expression into number multiplication. Suppose this is an it is a recursive rule, it is a production rule, but here expression, it generates expression itself. So expression, it is calling expression itself, so it is called a recursive rules. Now we can parse a sequence like Fred equal to 14 plus 23 minus 11 plus 7. Suppose one sentence, one sequence, one sentence we have Fred equal to 14 plus 23 minus 11 plus 7. Apply the this rule, what all things we can get it. So expression statement, statement equal to name equal to expression, as we saw in the previous grammar. Statement generates name equal to expression, and expression, since 14 plus 23 minus 11, so let us consider 14 plus 23 minus 11 as one expression and 7 is another expression. So we can write expression plus expression. So expression plus expression, where expression plus number, expression plus number. So here expression number is 7 and plus is plus, and expression, it can be this one entire thing, 14 plus 23 minus 11. Now this expression can also be split up into expression minus number, because there is, this is a grammar, expression minus number. So expression, this 14 plus 23 minus 11, how it can be split up? Expression, suppose 14 plus 23 is one expression, minus 11 is one number, minus 11. Now this expression, again 14 plus 23, it can be written as expression plus number, and this expression can be a number. So here you can see that expression can also be a number. So here some mistake is there, we can correct it. Here it is minus, and here it can be simply expression can be just a number. Yes. So now it is correct. So this is the parse tree for the input string 14 Fred equal to 14 plus 23 minus 11 plus 7 under the grammar, this one. Next is shift reduce parser. What is shift reduce parser? It attempts for the construction of parse in a similar manner as done in bottom of parsing. That is, parse tree is constructed from leaves to the root. So under the shift reduce parser, a parse tree will be generated from leaves to the root. We will start from leaves, that is bottom, and we will approach to the root. A more general form of shift reduce parser is LR parser, that is left to right parser. So the general form of shift reduce parser is LR parser. This parser requires some data structures. This parser requires some data structures, and that is an input buffer for storing the input string. What all data structure we need for shift reduce parser? An input buffer we need, and one stack we need. So input buffer to store the input string we need, and stack we need to store for storing and accessing the production rule. In stack, production rule will be stored, and input buffer, input string will be stored. Basic operations. So different basic operation, it can be shift, reduce, accept, or error. So shift, this involves moving of symbols from input buffer onto the stack. If you are moving any symbol from input buffer to the stack, then it is called shift operation. Reduce operation. If the handle appears on top of the stack, then its reduction by using appropriate production rule is done. So, like if some uh, expression is there and that can be reduced for, from RHS to LHS, then RHS of the production rule is popped out of the stack and LHS of production rule is pushed onto the stack. You will understand with one example. Simply just stating here. Except if only start symbol is present in the stack and the input buffer is empty, then parsing action is called except. In the stack, if only start symbol, that is dollar, is remain and input buffer is empty, then it is called that string is accepted. When accept action is obtained, it means successful parsing is done. If accept action is obtained, it means successful parsing is done. Error. When it is called error, this is the situation in which the parser can neither perform shift action nor reduce action and not even accept action. So if the parse neither a shift action is happening nor a parse is happening, uh, it is not reaching to accept action also, then it is called an error. For example, let us see one grammar. S generates S plus S, S generates S into S, and S generates ID. And perform a shift reduce parsing for the input string ID plus ID into ID maybe. So ID plus ID. So let us do. We'll see whether it is accepted or not. So as we said that there are two data structure we need. One is stack, another is input buffer. In the input buffer, input string will be there, that is ID plus ID plus ID, which is given here ID plus input string, and this is the grammar. Now dollar, first of all, I shift, we will shift the uh, uh, input data from input buffer to the stack. So ID will be shifted here. Shift. Then in this here ID, it can be S, because according to the grammar you can see that S generates ID. So RHS of the grammar production rule can be shifted with, can be changed with LHS S. So ID here it became S, and here action is reduced S to ID. Next, again plus will come, shift operation is happening plus, then again shift operation, ID will come here, ID. Again ID will be changed with S. So here reduce S to ID. S to ID is reduced. So S plus S. Now what is left here? Plus ID. Again reduce S to generates S plus S. It can be S plus S. S plus S can be uh, uh, changed with S, because S generates S plus S. So at this stage, S generates S plus, reduce S generates S plus, means S plus S will be reduced to S. So I have written it simple S. Then again shift plus will be there, then shift ID will be there, and here nothing is there. Input string is empty, input buffer is empty. Now this ID can shift, can reduce S to ID, so it will be S plus S. Now here S plus S. Now again S plus S can be reduced to S. So in this stack only S is left, that is starting symbol or input buffer is empty, means this string will be, this input string is accepted according to the grammar. For example, let us see another example. Consider the grammar E generates 2E2. and E generates 3E3 and E can generate 4. Perform shift reduce parsing for the input string 3 2 4 2 3. So in the input buffer we will be having 3 2 4 2 3 and stack will start with a dollar, and here shift operation will be there for 3. Now there is no reduce operation for 3. 4 operation reduce operation is there for 4. So next shift operation will be there 3 2. Again for a 3 2 there is no reduce operation. Then again 4 operation will come 3 2 4. But 4 there is reduce operation. 4 can be changed with E. So 4 is changed with E. So here reduce operation is happening. E generates 4. So here 4 is next again 2 will come. Next shift 2 will come here. So 2E2. 2E2. Again 2E2 reduce operation can happen because 2E2 can be replaced with E. So reduce by E generates 2E2. So 2E2 will be shift reduced to E. Again 3E and here 3 is there. Again 3 will shift here, shift 3. So 3E3 it can be reduced to E. So reduce E 3E3. So again reduce. So again here at the end in the stack, the starting symbol which is E is left and input buffer is empty. So this is accepted. This string is also accepted. Now the next topic is what Yak cannot parse. What Yak cannot parse. So Yak can parse all the string, but a few things it cannot parse, which is called ambiguous grammar. Let us see example. It cannot deal with ambiguous grammars, one in which the same input can match more than one parse. If using the grammar, if we can generate two parse tree for the same input symbol, same input string, then it is called ambiguous grammar. So Yak cannot parse the ambiguous grammar. For example, let us see. It also cannot deal with grammars that need more than one token of look ahead to tell whether it has matched a rule. It also it will also not parse grammar for more than one look ahead token. What is more than one look ahead token? We will see here. Let us see one grammar. Phrase generates cart minus animal and cart. Cart animal. It is not minus. It is cart underscore animal. Or phrase can generate be work animal and plow. Cart animal, it can be horse or goat, and work animal it can be horse or ox. Now this grammar is not ambiguous since there is only one possible parse tree for any valid input, but Yak cannot handle it because it requires two symbols of look ahead. It is not an ambiguous. Because for any input string it generates only one parse tree, but it is not look ahead one. It to identify it has to look two uh, steps forward. For example, in particular, in the input horse and cart, horse, cart, horse and cart, it cannot tell whether horse is a cart animal or work animal because horse belongs to both cart animal or also a work animal. If we say horse and cart, so what it will, whether you can say it is a cart animal or work animal. The first horse it belongs to both, but since cart is there, to see the cart we have to check again this. So in particular, in the input horse and cart, it cannot tell whether horse is a cart animal or work animal until it sees the cart. When it sees the cart, then only it will be clarified. Yeah, it is a cart animal, and yak cannot look that far ahead. But here, a yak cannot look more than one step, so it will not be passed by yak, though it is not ambiguous, but since it is not look ahead one. In the next lecture video, we will be discussing yak parser, the definition section and the rule section. Thank you.